This video looks at parallel and perpendicular vectors. Now we're going to look at it in relation to the dot product, which we've just looked at. Now, parallel first. We can have parallel vectors in the same direction, or we can have parallel vectors that are going in the opposite direction. So you can see examples that I have here. I have vector A and vector B, which are in the same direction, and then I have vector A and vector B, which are in the opposite directions. Now remember, as long as they have the same direction, which it kind of looks like here, and what I mean by that, to be able to check, this angle theta needs to be the same, then those vectors are parallel. I just don't want you to look at the diagram that I've provided and think they have to be on top of each other. Similarly, I could have A here, and I can have B over here. They are still parallel vectors. If I found that reference angle, that theta, and this theta here, they would be the same angle. So these vectors are parallel but in the opposite direction. Okay, so don't lose sight of that. I know these diagrams can help you do that, to make you think, oh, they have to be on top of each other. They don't. Now, if you have parallel vectors in the same direction, the angle between them is 0. If you have parallel vectors in opposite directions, then the angle between them is 180 degrees. Okay, now looking at our dot product formula, we have magnitude of vector A times the magnitude of vector B times by cos of theta. That theta, if we're in the same direction for parallel vectors, is 0. Cos of 0 is 1. Go back to your unit circle knowledge from year 10. You should realize cos is my x coordinate. So a quick review of unit circle. This is the point 1, 0. Cos is our x value, our cos theta is x. So you can see that when my angle is 0, cos theta is going to be 1. So that means for parallel vectors in the same direction, my dot product is simply the magnitude of A times the magnitude of B. Okay, now this helps because we might get asked, are these vectors parallel? So if we work out that the dot product is the same as the magnitude of A times the magnitude of B, then we can say they're parallel vectors. Now, if they're parallel in the opposite direction, our theta is 180 degrees. Going back to our unit circle, we're now over this side, and that coordinate is -1, 0. So cos of 180 is -1. So our dot product between A and vectors A and B is negative the magnitude of A times the magnitude of B. So you've just got this negative out the front. Now following on from this, if vector A is parallel to vector B, then vector A is going to be a scalar multiple of vector B. Putting that into context, if we have vector A equals 2i plus 3j and vector B equals 6i plus 9j, which is the same as 3 all outside of 2i plus 3j, and what you should see there is here is my vector A. So that can be rewritten as 3a. So my scalar, my k value, is 3. Okay, so you've got two ways of finding out whether you've got parallel vectors. Number one, the dot product has to be the magnitude or the magnitude of one vector times by the magnitude of the other vector, or the product of the magnitude of the two vectors. So if you have that, or the dot product is the negative of the product of the two magnitudes, then yes, they're parallel. Or you can just look at the two vectors in Cartesian form and see that one is a multiple of the other. Now, for perpendicular vectors, you have a right angle between vector A and vector B. So you can see that in this diagram here. So that means my theta, the angle between the two vectors, is 90 degrees. Now, going back to that little unit circle diagram, I'm now up here. That is 0, 1. So cos of 90 is 0. So that means if we replace our cos of theta with cos of 90, and that is 0, then my dot product is 0. So if my dot product is 0, I know the two vectors are perpendicular. Now for our unit vectors, the dot product between two unit vectors has to be 1. And that's because the angle is 0. So for our unit vectors, the magnitude of a unit vector is 1. So our dot product is 1 times 1, which is 1. Now you need to make a correction. This is 0. So for perpendicular vectors, we know the dot product is 0. So for our I and j unit vectors, the dot product must be 0. You probably should watch this video again. Just really cement it in your mind. This is going to come up a lot, so make sure you understand it.